So we're starting talking about factoring. Some of you will have seen this a little bit, and for some of you it's brand new, although the working with factors of numbers is something you do in elementary school, so you would have seen it in elementary school, you just might not have seen it last year. So we're going to do two specific different kinds of factoring, and we're starting one of them today. It's called common factoring. Before we do that, we're going to talk a little bit about what factors even means. But it's quite new and quite different in a lot of ways. So what is a factor of something? Does anybody know? Anybody want to take a guess? Thomas? Kind of. A multiple of 3 would be like 6, 9, 12, 15. So things that 3 multiplies to. So a factor is kind of the opposite. So if I say, give me a factor of 15, 3 is one of the factors of 15. So factors divide evenly into the thing that you're talking about. Okay, that's what a factor, it even says right there, look, factors of a term are things that divide evenly into it. And then it's kind of nice, you can come up with pairs of factors that multiply to your number. So what are 2 factors of 24 that multiply to 24? 2 and 12, good. Ethan, what were you going to say? Same thing. Is there any others? 6 and 4, okay, and there's lots of others, 3 and 8. 1 and 24, that's always an easy one, right? So there's plenty. Some numbers have lots, some numbers don't. And in fact, have you ever heard of a prime number? This isn't really part of our lesson, but you've heard of a prime number before? So a prime number is something that has exactly 2 factors, 1 and itself, like 2 and 3 and 5 and 7 and 11 and so on, right? So 5 is only divisible by 1 in itself, so it's prime. It has no other factors. Anyway, and prime numbers are something that mathematicians love and are very curious about. So we have to be able to find factors of things. You won't be able to common factor or do the factoring that we're going to start in a couple of days without being able to kind of find factors in your head. So don't shout anything out, but everybody, I want you to think about this for a minute. In your head, what are the factors of the number 8? So what numbers divide evenly into 8? Now, if that's something that you find very difficult, you're like, I really have no idea, I don't know where to start, I'm not sure what to do, that is tricky because there's no algorithm short of taking your calculator and just going, okay, so I'll try everything. 8 divided by 1, oh, it worked. 8 divided by 2, it worked. 8 divided by 3, it didn't. 8 divided by 4, it did. 8 divided by 5, it didn't. 8 divided by 6, it didn't. It would take a long time to try every number and see if it's a factor of 8. I have another trick, and we'll do that a little bit later, that can help if you're not able to do it in your head. But doing it in your head, if you can, is the best thing because it makes it a lot faster and it'll make it click a little bit more. Okay, so that's kind of what we're going to be doing. We're going to do a few activities to help you practice coming up with these factors. So the first one, state the factors of 16. Now we're going to try to list them in order. Okay? And so I'm going to start with 1. Because 1 is a factor of anything. You can always start with 1. Somebody give me the next. 2. 2's an easy one because every even number has 2 as a factor. So 2's an easy one. If it's even, you start with 1 and 2. Okay? And then hopefully not on your calculator, but in your head, you probably kind of go through the list. Well, what about 3? Does 3 go into 16 evenly? Taylor, what do you think? So 3, and you can figure it out by counting by 3s, like in your head if you have to. 3, 6, 9, 12, 15, 18. So it doesn't, right? Good, so 3's no good. What about 4? Does 4 go into 16? Yes, it does. 4 times itself, 4 times 4. Okay, 6, 7, 8. And when you get better at this, you kind of get to a point you're like, okay, there's nothing else. 8 is half of 16, so there's not anything else until we get to 16, right? Okay, and 24 is a big one. Try 24. So again, we'll get started together here. 1, 2, because it's even. It doesn't have to be in order. I'm going to write them in order. Yours doesn't have to be in order. It's a little bit easier if you can do it in order. So go ahead and see if you can finish that list. All right, how are we doing? So hopefully you tried to get a few of those. It can be hard at first, but it's one of those things where you can get warmed up and start to get better at it. So keep trying. I gave everybody a multiplication table or multiplication and division table. And how do you use this to find factors? Well, if we're looking for 24, I'm just going to run through the list and I'm going to look for the number 24 in the table, not up here at the top or on the side in the table. So bam, there's 24. And you want to watch carefully. What does that tell me? It tells me 12 and 2 are both factors of 24 because they multiply to 24. Okay, let's look for another one. There's 24. 8 and 3 are both factors. There's 24. 6 and 4. There's 24 again. 4 and 6, so that's the same. 24, 3 and 8 is the same. 24, 2 and 12 is the same. And so if we write those down, it's not a guarantee because especially when you get to bigger numbers, it might go off the table. But that's a pretty good indication that you got all of them, at least all the ones that are on the sheet. So 3, 4, 6, 8, 12, and 24. 5 doesn't work, 7 doesn't work, 9 and 10 don't work, 11, 13, 14, 15, 16, 17, none of those work, right? So I think we have a pretty good list. Now here's the trick. Look at 16 and look at 24. Which ones do they have in common? Ethan?
8, 4, 2, 1.
So 8, 4, 2, and 1, they'll always have 1 in common because 1 goes into everything. So it's not usually useful, but it might be our answer in some cases. So what's the next line say? What is the greatest common factor? So what is it? It's 8. Because 8 is in both lists. So this is what we're going to practice for the next 10 or 15 minutes, is trying to come up with the greatest common factor just between two numbers. Writing out the list like this is the slow way of doing it. Eventually you want to get to a point where you're making the lists in your head, but that some people are better at that than others. So if coming up with it in your head isn't the best thing, then by all means, for now at least, write out the list, but you'll notice down the road that it'll get very tedious and slow if you have to write down the entire list the entire time. Okay, so let's try a few more together. State the GCF of each of the following sets of numbers. So 5 and 15, what is the greatest common factor between those two? Don't shout it out, don't answer it. Answer it on your page if you have to. You don't have to list them, but you can if you want. Josh, what are the factors of 5?
1 and 5.
1 and 5, nice. That means it's prime, very good. It's an easy one. Okay, and if you're not done already, try 15. Jake, can you do 15?
5, 3, 1.
Anything else? 15. And you might think, well, obviously, like so, but that is an important part of your list. So the number itself, you have to consider now. So it's obvious, right, that it'll always work. 1 and the number will always work. Okay, and so then what's the GCF? 5. Because 5 is in both lists. Okay, try 8 and 18. Oh, so this first one is an example where one of the numbers is the GCF. And in fact, there's a shortcut. You can ask yourself, does 5 go into 15? Yes. Then it's the greatest common factor. Because nothing bigger than 5 will ever go into 5. So if one of the numbers goes into the other, then it's the GCF. But you notice 8 does not go into 18. So now you have to go hunting. So the GCF between 8 and 18, Ethan? 2, very good. 18 has a lot of factors, so it seems strange that 2 is the biggest because it's pretty small, but sometimes that happens. And the last one. $40 is an example of a number that's going to go off this multiplication table. Now, if you find yourself really counting on this multiplication table, I have a bigger one that goes up to a much higher numbers, like 20 and 25 or something. So I'll be happy to give it to you. Some people use it and some people don't. Does anybody know what the GCF of these 3 are? So it's got to be in all 3. Tim? 4. Very good. I think he's right. So I'm going to give you a sheet to practice. We're going to take about maybe 10 minutes, or maybe even a little bit less, to practice this, and then we're going to add something else onto it.